This is a theory question come from British Math Olympia 2014. Suppose m and p are integers such that p equals to m times n plus 9 equals to n times n plus 6. We are asked to find all possible value of p. There are two techniques that we have to use in this case. Number one, complete the square, and number two, factorization. So first of all, we look at the equation m plus 9 equals to n plus 6, m squared plus 9m, and on right hand side it is n squared plus 6n. On the right hand side it is easier to understand. Then we are trying to complete the square. For those who are not very familiar with completing the square, there is a one nice explanation for the idea of completing square. That is, we treat n square as the area of a square of side length n. So n square is the area of this square. For 6n, we'll split into 3n plus 3n. Each of these is the area of the rectangle with dimension 3 by n. And we complete the square by inserting one more square of side length 3. So this square will have the area 9. With plus 9 and minus 9, then later on we can complete the square here. That is n plus 3 square. Because a bigger square have the side length n plus 3. And we copy down the negative 9 here. How about for m squared plus 9m? We do the similar thing, and we start with m and m. After that, for 9m, we split into two of them, and one of it is 9 over 2m, and the other one is 9 over 2 and m. And we complete the square by insert another square of side length 9 over 2. The area will be equal to 81 over 4. So plus 81 over 4 minus 81 over 4. And the first three terms will give us m plus 9 over 2 square. And the last one just remain the same. And note that there are fractions in the left hand side. In order to avoid the fraction, we can multiply each of the term by 4. And this will give us 2m plus 9 square minus 81. And this is 2n plus 6 square minus 36. And therefore, this is 2m plus 9 square minus 2m plus 6 square equals to 81 minus 36, that is 45. So now we will let x as 2n plus 9 and y as 2n plus 6. So this equation will become x squared minus y squared equals to 45. I'll erase this part to save the space. Note that there are many factors of 45. Factors of 45 are 1, 3, 5, 9, 15, and 45. There are 6 positive factors and also 6 negative factors. Now, note that x squared minus y squared can be written as x plus y, x minus y. And note that each of the x plus y and x minus y must be an integer. And 45 can be always split into two integers, either 145, 315, 5 and 9, or negative 1, negative 45, negative 3, negative 15, negative 5, and negative 9. So there are many cases to consider, but we will see that the main task for this question is to find all possible value of p, not all possible value of x and y, not all possible value for m and n. What does it mean? So it means that if x plus y equals to k for some positive or negative factors of 45, then x minus y will be equal to 45 over k. Then this will mean that x equals to half of k plus 45 over k. We simply add these two and divide it by 2. We'll get x. Likewise, for y, it is half k minus 45 over k. If x plus y, x minus y equals to k and 45 over k, the x will be equal to this value. And this will be the same if x plus y equals to 45 over k and y equals to k. The value of x will still equals to the same as the value of the x here. And which means that with the same value of x, we obtain the same value of m. With the same value of m, eventually you will get the same value of p. In conclusion, these two different values of x plus y, x minus y will give us exactly the same value of p. Likewise, if x plus y equals to negative 45 over k and x minus y equals to negative k, these two cases will give me exactly the same value of y. Of course, if this is equal to negative k, negative 45 over k, and these two sets will give us exactly the same value of y. So in short, for these four different values of x plus y, x minus y, eventually all will give us the same value of p. It means that we only need to consider positive value of k, whereby k equals to 1, 3, or 5. Otherwise, the value of p will be all repeated. This will save us a lot of work. So if k equals to 1, if k equals to 1, then the x will equals to half of 1 plus 45, that is half of 46, that is 23. If x equals to 23, then m will equals to 23 minus 9, that is 14, divided by 2, that is 7. So x equals 23, m will equal to 7, and eventually p will equal to 7 times 16, that is 112. K equals to 3, x will equal to half 3 plus 15. 3 plus 15 is 18, divided by 2, that is 9. When x equals to 9, m is equal to 0. Obviously, when m equals to 0, p is equal to 0. K equals to 5, x is equal to half of 5 plus 9, and that is 14 over 2, that is 7. When x equals to 7, m is equal to negative 1, and therefore p equals to a negative 8. So the positive value of p will be 112, 0, and negative 8. But we have to make sure that for this value of m, there is a corresponding integer value of n. Otherwise, this may not be achievable. For m equals to 7 and n equals to negative 14, both of these will give us m equals to 112. So p equals to 112 is achievable. And for p equals to 0, this is something that are very simple to get p equals to 0, because if mn equals to 0, 0, then p is 0. Or when m is 0 and n equals to negative 6, p is also equals to 0. When n equals to negative 6 and m equals to negative 9, p also equals to 0. And when m equals to negative 9, n equals to 0, p also equals to 0. These four cases were corresponding to these four cases that I discussed just now. So p equals to 0 is something that very obvious. And finally, we need to check that when m equals to negative 1, there is a corresponding value of n such that p equals to negative 8, and the value of n equals to a negative 4. So we conclude that p equals to 112, p equals to 0, and p equals to negative 8 are all its possible value. With this, we have done this question. As usual, I prepared something similar to this question. You can have a good try of it and check your answer in the description. That's all for today's lesson. I'll see you again. Bye bye.